So we are here with problem one, and you can see I've already copied all of my data in for each of these problems right out of the presentation. So feel free to do the same. It's much easier than typing it by hand. For problem one, I made this one up using real data. The table gives the median household income for families in the US, and I know we did one like this in the examples up here, but this is more recent data, and so it's kind of cool. No, actually, we did. Yeah, we did one like this, maybe in a different section or something. I can't remember. So we're going to find both a linear and a cubic model that represents the data. We're going to use the model that we feel fits better to predict the median income in the year 2020. And then, when does your model predict the median income will reach $100,000, and does it ever? So again, we don't want these as x values because they're huge numbers, and so it creates problems making the equation. So we're going to create a column and call it years past 1985. And so for this one, or you could even do years past 1980, you would end up with basically the same thing. So years past 1985 is 0, that's 5, that's 10, 15, 20, 25, and 30. Those are going to be much nicer numbers to use to make the equations. So again, everyone, we go insert chart, and we get this funky scatter chart. The crazy thing is it doesn't look like the median household income has gone up or down a huge, significant amount since 1985. That's kind of wacky. So anyway, we're going to go to series. We want a trend line, and we want a linear one to start with. This linear one looks like it fits the data okay, but not the greatest. And again, we need the label use equation, and that will bring our equation up. So there we go. So linear model, right there. And again, customize and series. We're going to look for, what is it in this case, a cubic. Cubic is polynomial to the power of 3. And that one seems like it fits it a little bit better, I guess. So I'll go ahead and use the cubic when I do my work going forward, everyone. If you choose to use the linear, you're not going to be wrong. It just seems to me like the cubic model fits it a little bit better. And so we're going to predict the median household income in the year 2020. So with that, the year 2020 is 35 years after 1985. And so we'll take our cubic model, slap it into Wolfram, and we're going to replace our x's with the number 35. So it looks like our result is $61,510.25. 6, 15, 10, 25. So the cubic model predicts that in 2020, median household income in the US will be about $61,510.25. I am going to fact check that in just a minute and see what we got. And then, when does your model predict the median household income will reach 100,000, and does it ever? So what we've got to do, everyone, is take our cubic model again. And that was part B right there, right? So I'll label. And we're going to be on part C. So I've got my cubic equation copied. We want to see if that is ever equal to $100,000. And again, we get imaginary numbers. No, we do get a real solution also. Good. So it predicts that 64.6, so about 65 years after 1985. So 1985 plus 65 is the year 2050. So this model predicts that in the year 2050, the median household income in the United States will be $100,000. I suppose we'll have to wait and see.